The next topic is pre-deployment surveys. The first one, which we will discuss in this video, is a predictive survey. Okay. So, a predictive coverage analysis is accomplished using an application that creates visual models of RH coverage cells. Okay. So basically, this application has or provides RF simulations and modeling design capabilities. So what you need to do is you have a software which is, let's say, inbuilt into a laptop, or you install it in a laptop, and then that software lets you import a map, a floor plan. Okay. And then on that floor plan, the first thing you do is, let's do this. So upload a floor plan into the software. The floor plan can be a CAD file, a DWG file, and a PDF file, or a PNG image, depending on the kind of software that you're using. The second thing you do is you scale a map. You mark the measurements in the map, as you know, the distance between the 2 points. You can mark that, and the whole map will get scaled. The third thing is that you start marking the or drawing the attenuations. What it means is, attenuations mean loss, so loss of signal. So if there is a concrete wall, or if there is a glass room, or some wooden tables or a door, then you need to mark them with the right attenuation. The tool already has inbuilt attenuations for different things, which can be found on the floor. Let's say it's an enterprise office, you'll have something like a wooden table, or a wooden door, or you can have attenuations marked for brick wall, concrete wall, drywall. For warehouses, deployments, or manufacturing plants, you can have something like a metal shelf, which you can also mark, and then corresponding attenuation will already be applied, so that when you place an access point on the map, it knows how much RF signal will be lost, right? So mark the attenuation, and then you start placing APs. You need to know, according to the requirement, you need to know which APs to put. And then once you start placing the APs here manually, you'll understand how the coverage will look like. And it's gonna show you, on the screen itself. It'll run a simulation for you and tell you how much coverage this AP will bring in, how much overlap will these two APs bring in, and how much will the RSSI value on the ground will be, how much will the SNR be, and basically the primary coverage. You also have to worry about something called a secondary coverage in good designs. A lot of customers, when they do a site survey, or when they ask for someone to do a site survey, they don't discuss this. But secondary coverage is becomes critical in on the ground when the clients are using sensitive applications. So it simply means, if I'm standing right here, and I need approximately around minus 70 dBm of signal to do what I'm doing on the ground. So I'm getting that signal from this AP. Okay. Now if this AP fails, this is the primary coverage that I'm getting. Now if this AP fails, there has to be another AP in the vicinity which should be able to support me if the AP goes down. So that is called the secondary coverage, the coverage from the secondary AP if my primary AP fails. So that's extremely critical, because it kind of gives you a backup plan in case my AP goes down. So that's something which you need to also take care of during this predictive design. So what this software does is really, it creates a forecast model using the predictive algorithm. So the algorithms are already fed in the software, and the attenuation information, which I already talked about. So what it does is it runs the algorithms with that, and understands the data that you fed in, runs the algorithms, and gives you something like, some different patterns. Like, it could be a channel reuse pattern. It could tell you, how much channels you are reusing. It could tell you about the coverage cell boundaries. It can tell you this. It can also tell you some different AP placements, where you can place the AP, and how much would be the appropriate RSSI and the SNR value from the signal if you place the AP right here. How many APs you need, number of APs. It'll tell you that as well, how many APs you need, to cover this much area. By the way, on the floor plan, there is a tool called the if you wanna just remove some area from coverage, if you wanna tell the tool that okay, I don't need coverage in this area, you can mark that area with the tool which says okay that this much coverage, RF coverage, not needed. You can exclude this area, so it's more like an excluded area. So the APs or the tool does not consider that area when it draws the RF coverage pattern for you. Okay, it can tell you data rates also, that the clients should be able to see if he's at a particular location on the ground. By the way, all this is simulated. This is not original. Okay, this is like not absolutely exact, because we're just trying to simulate the environment which we saw from the floor plan. Now, the challenge with this is that even though this is uh, done remotely, you just need to ask for a floor plan and ask for those basic prerequisites which we talked about in the last few videos. You need that information, and then done remotely. This is quicker, so it saves a lot of time, but it is less accurate. Okay. The one thing that you have to do in this is, if you get a floor plan from the customer, you need to spend a few hours to understand the floor plan first. Okay, because in an enterprise office you'll see some cabins, you'll see some corridors, you'll see some some areas where you'll find more density. So you need to understand the entry points and the exit points of the users, and you need to check with the customer on a call as to how are the users moving around in the floor, are they static, are they really mobile all the time, and understand the floor plan first. If possible, I would say, if it is possible for you, go visit the site. You should always go, once you get the floor plan, take a walk, go visit the site, take somebody from the customer end, and walk around with him and verify the floor plan. Okay, verify the floor. This is what I usually do, because if I get a floor plan and the customer is living in the same city, I usually take a printout of the floor plan, go and visit the customer office, and then walk around in the office to see what he gave me in the floor plan is that identical to what I see on the ground in real time. Because many times the floor plans were printed long before some changes done on the floor. You might see an extra cabin here and there which never existed on the floor plan. So you have to make sure that that particular floor plan which you got is exactly, at least as exact as it can be. But if there's any variation in real time, then you should know beforehand, so that you can plan accordingly in the design that you do. So ask questions, get all the information. This is done remotely. You don't need a lot of manpower to do that. One person can cover a building in a few days. It's faster. You actually spend a very less time in doing this compared to the other type of other type of pre-deployment survey. It's less accurate. I would say it's somewhere around 70 to 80% accurate. Okay. Now, most people will go with a predictive design because it gives them a basic idea about how the AP placement should look like. It gives them, some points where okay, AP should be placed here, AP should be placed here. If I do this and send it to the customer, I create a whole report. So tools like Ekahau, these software tools like Ekahau, Air Magnet are the known ones in the market. So I usually use Ekahau, but a lot of people use Air Magnet also, which is a very good tool. Now, if so, these softwares also give us, or these tools also give us the privilege to take out the entire report at the end of the site survey, which has the details about a lot of things: the RSSI, SNR, AP placement, AP names, naming convention, you name it. It's a detailed report of 30-40 pages, which you can take out, and then you can share that with the customer. So based on that, if I get the AP positions, at least I have a basic idea as to where to place the APs. Now, a predictive survey, once the predictive AP positions, we get the location of the APs. Now, once the APs are deployed based on this, when RRM works on top, radio resource management, okay, the issues are almost I mean, I would say 99% of the issues are remediated if the RRM works properly. But if you don't do a predictive design, if you don't do a pre-deployment survey, and then you just rely on RRM, it may not solve the purpose for you, because RRM can fix, you know, can only do so much. You cannot just deploy a network without any training and then expect RRM to fix everything for you. That's not going to happen. Okay, it cannot just be magical for you. It can help you a bit, but it cannot really create everything on its own. So do a predictive analysis, do a pre-deployment survey, and then let it work with RRM. Hopefully your network will be untouchable after some time. So now that's what I wanted to cover in the predictive analysis. Nowadays, Ekaho and Air Magnet are the ones which people usually use, but there are other tools also coming out in the market nowadays which are as good as these. But yeah, they're not as famous as Ekaho and Air Magnet. But yeah, you can explore more tools if you want. But I usually work with Ekaho, which is tried and tested. Okay, cool. Thank you so much.